Today what we're going to talk about is how to represent data in other ways. Last time we discussed frequency distributions and how to represent their data, which was usually in histograms, frequency polygons, ogives. This time what we're going to talk about is how to represent some of the categorical data in other ways. The first way is looking at our bar graphs. And bar graphs are a way to represent data in either vertical or horizontal lines. These are used for qualitative data, our categorical data. And they can be used to compare groups. Normally we just use them for one set, but sometimes we use them for both and put both types on there. So let's look at an example and see what we have. Here is a chain, and we have the worldwide sales for these 5 different fast food franchises. Wendy's has $8.7 billion worth of sales. KFC has $14.2 billion worth of worldwide sales. Pizza Hut has 9.3, Burger King has 12.7, and Subway has 10. So how can we represent this data in a graph format? One way is a horizontal bar graph. What I've done here is I've taken the data in the previous table, right here, and literally said, okay, what is the worldwide sales for each category, and drawn a bar for it. So Wendy's had $8.7 million, and so the sales, which are, since it is a horizontal bar graph, is along the x-axis. Make sure that you label your axes. So I've got sales in billions down here. And let's see here, here's 1, 2, 3, 4, 5, 6, 7, 8 billion, and so it's a little over 8 billion, so it's 8.7. Then KFC was 14.2, and so we're a little over 14. Pizza Hut was at 9.3, so a little over 9. Burger King was at 12.7, so we're almost at the 13 mark, but not quite. And Subway was right at the 10 mark. So each one has a bar that represents their number of sales, and they're horizontally, so a horizontal bar graph. We can also represent it in a vertical bar graph, such as I've done here. In a vertical bar graph, my sales are along the y-axis, and my categories are along my x-axis. And it's the same thing. I've kind of squinched my bars down. I've counted by 2s instead of by 1s in my cells. As long as you count by the same increments, it is fine. In other words, I can't go 2, 3, 6, 7. I've got to be consistent. I've either got to count 1, 2, 3, or I've got to say 2, 4, 6. In other words, my scale has to be the same throughout my entire graph. So a vertical or horizontal bar graph is one way of representing data. Another way is what we call a Pareto chart. A Pareto chart also is used for categorical data. Here the bars must touch just like in a histogram. So the bars are going to touch, and we do have to make sure that we take note of this fact right here. The bars must go in order from highest to lowest. So if they do not give you the data in order from least to greatest or highest to lowest, you need to put it in order. That's going to be your first step when you're working with a Pareto, and make sure that that data is in order so that your chart will look, when you graph it, it stair steps down, okay? And so it would look something like this, or it could be something like this, depending upon your data. Okay, but it needs to make sure that it goes down in the order. So let's look at an example. The data in billions shows the estimated amount of money spent on pet care in the US. Construct a Pareto chart for the data. So here is the data. So we have type of care and the amount spent. So in the US, we spent $14 billion on veterinary care. We spent $11 billion on supplies and medicine for pets. We spent $4 billion on grooming and boarding for pets, and $2 billion on animal purchases, meaning the actual purchase of the animal. Notice that my data is actually already in order from my highest to my lowest in this particular chart, which is good. Again, if it's not, make sure that you do that. So whenever I come over here to graph it, I have my vet care, then I have my supply of medicine that was at $11 billion. I have my grooming and boarding, which was at $4 billion, and then I have my animal purchases, which was at $2 billion. Remember, I have labeled my axis over here to let me know what this represents. Make sure that your bars have the same width and that they're arranged in order from largest to smallest. Also, make sure that you're counting the scale on your y-axis in the same way. If I go 2, 4, 6, 8, or if I say 1, 2, 3, 4, I need to make sure that they're evenly spaced as well. Okay? So we've looked at two types of charts that can represent categorical data, and one of them was the bar graphs, one of them is the Pareto. The bar graphs, it doesn't matter what order it's in. The Pareto, you have to make sure that it's in highest to lowest order. A third type of graph that we used is a time series graph. A time series graph is a line graph that represents data collected over time. We see these a lot when we're talking about different types of data where it shows the increase in the population over time or the increase in price over time, anything like that. Those are types of time series. Your time goes along the x-axis. So for instance, your years would be down here, and whatever you're talking about, money, enrollment, things like that, would be along the y-axis. And then it says the dots must be connected, so it's going to look something like this, depending upon what your data shows. So let's look at an example. The average amount of money spent by consumers on Valentine's Day is shown in the chart. Draw a time series graph for the data. So we have the data for 2007 through 2012. So in 2007, on average, people spent $120 on Valentine's Day. And then we see that it went up to 123, then back down to 103. In 2010, it stayed at 103. Then in 2011, we started to increase to 110. Then in 2012, we spent on average $126 for Valentine's Day. So let's see what the graph looks like. Notice my dates, my years, are along the x-axis, and they go in order. So 2007, 2008, 2009, 2010, 11, and 12. And then the amount that I spent goes along the y-axis. And I've counted by twos. I start out at 102, and then 4, 6, 8, 110, and all the way up. And so in 2007, it said that we were spending $120 on average. 2008, we went up to $123. 2009, we came down here to $103. 2010, we stayed at $103. Then we went up to $110. And then in 2012, we were all the way up to $126. Notice that in between 2008 and 2009, we had a drastic decrease. Could have been due to maybe the economy, unemployment rates, things like that. And then these last 2 years here, it's begun to go up. It'd be interesting to see what 2013, 14, and 15 would be, to see whether the statement about due to the economy would hold true or not. So a time series chart, again, it's a line graph, and we just need to make sure that we connect the dots. I do not come back to the axes because I don't have a zero. I just start wherever the data gives me, and I connect all my points. Another type of graph that we use a lot is the pie chart, pie graph. It's used to show relationships of part to whole. You can use percentages or proportions, and it's used for categorical data. Once you get the percentage of an item, like we did back in chapter 2 or in section 2.1, you can estimate on the pie graph. Just make sure that when you're estimating and everything, if it says that something was 24%, you know that that's about a quarter. So this could be represented by 24%. I don't want to see something that looks like this is 24%. Okay? Be reasonable on your drawings, on your estimations for your pie charts. Not going to make you actually calculate the number of degrees. We're just going to estimate once we get those percentages and then draw those in. Okay, now then, a stem leaf plot. We do use these quite a bit. They're used to, we use the data to create what we call a stem and a leaf. We arrange the data in order from least to greatest. And a key thing here is we cannot skip a stem. And I'll explain the difference between what we call a stem and a leaf in just a moment. Only the last digit of a number is your leaf. So for instance, if I have the number 128, the 8 is going to be my leaf. The 12 right here is going to be my stem. So it's only the last digit in my numbers that is going to be the leaf. Everything else in front is going to be the stem. Even if I have the number of 600, let me try rewriting that again, getting a little bit off there. If I have the number 6,789, only the 9 is my leaf. The 678 is my stem. Okay, so it's only the last digit that's going to be my leaf. Now, when we're talking about you cannot skip a stem, if we're looking at a stem leaf plot, if I was going from 128 to 6,789, I would have to fill in everything from 13, 14, all the way up through 677 in my stems. I could not skip anything. So stem leaf plots, we wouldn't want to have something that has a huge range like this. We could, but most of the time it's for smaller ranges and items like that. So let's look at an example. We have the numbers 61, 67, 65, 70, 78, 80, 76, 77, and 66. And we want to create a stem leaf plot with this. So what we're first going to do is put these in order from least to greatest. And so let's see here, 61 is my smallest number. And then it looks like 65, and then 66, then 67, then I have a 70, I have 76, I have two 77s and I need to write both of them down. I have a 78 and I have an 80. So now my data is ranged in order from least to greatest. So I'm going to have my stem and my leaf. So if you notice, I go from 60s to my 80s. So my stems are going to be 6, 7, and 8. This represents 60s, this represents 70s, and this represents the 80s. My leaves are going to be a 1, 5, 6, and 7. And I try to evenly space my leaves out. So I try to have a little bit of space in between them. And I'm going to try to keep them in the same column as I go down. Okay, and I need to put these in order from least to greatest. So I should not have the 7 here in front of the 1 or anything like that. That's why we put them in order from least to greatest to start out with. Now then, with my 70s, I have a 0, I have a 6, I have two 77s. I need to write both of those down. And then I have an 8. Again, notice that I have tried to keep things fairly lined up. Again, since I had two 77s, I needed to write down the 7 twice here. And then in the 80s, I just had a 0. And what you can do is, using this particular stem leaf plot, you can kind of look and see what type of histogram it might make, because these are like 1 column, 2 columns, 3 columns. And so if I were to come over here and draw a histogram, it would kind of look like this, go up one more, and then come down drastically. In other words, my numbers here are my frequencies that I'm talking about. Okay? And so that's one thing that we can use it for, is how do we look at these and what is their purpose? Make sure that you put all of your data values in your leaf area, and again, make sure that you do not skip a stem. Even if there's no number in that area, we cannot skip a particular stem. Okay? So we've looked at 5 different types of ways to represent data: the bar graphs, the Pareto, the time series chart, the pie graph, and now then the stem leaf plot. So make sure that you do some practice with these, and then let me know if you have any questions.